Hello everyone, I am Tanya and I am a data science intern here at Kryzotech. So today we are going to perform sentiment analysis on the Amazon Alexa review dataset. So this dataset is publicly available online on Kaggle and various other platforms. We will take the dataset and we can use it. We will analyze it in our cut. So to give an overview about the dataset, we are analyzing the Amazon Alexa reviews. So this dataset is in TSV format and it is available on various sources online. You can also find in the Kryzotech's GitHub account. Alright, so firstly we are going to import all the required libraries. You can use the requirements.txt to install all of them. Then after that we will load our dataset into our data variable, and if we look here, the dataset has around 3150 rows and 5 columns. So the columns are rating, date, variation, verified reviews and feedback. So as you can see, the rating column will tell us about the ratings of that particular Alexa. Then we got variation. Variation is basically which model of the Alexa the review is about. And then we have verified reviews and then the feedback. So if we check the column names, we got rating, date, variation, verified reviews, feedback. Then the first step is to check for the null values. So if we look here, we got one null value in the verified reviews column, and if we check that, it is in the 473 row that we have a none value for the verified reviews. So we can drop this column since it is only a single value. Then again we print the shape of the dataset. It is now having 3149 rows and 5 columns. So next we will create a length column. This length column will contain the length of all the verified reviews. So we do this, we are simply applying using the length function, and we are applying it on the verified reviews column, and we can see that here these are the reviews and these are the length of that particular review. So we can also see that just to verify it, we can see that we are getting the 10th column from here. We're getting the verified reviews, then length of the review and actual length in the column value. So if we see here, the verified review column value is this, and length of review is for 65, and the actual length column value is also 65, which thus verifies that our data in the length column is correct. Next we check the data types of all the features. So we got rating, feedback and length as integer, and we got date, variation and verified reviews as string. So analyzing with the rating column, this column refers to the rating of the variation given by the user, meaning out of 5 stars how many stars had the user given to that Alexa. So if we check, there are around 3149 records, which means no null value in this column. If we look at the different values which are present in the rating columns, we get that there are 5, 4, 1, 3, 2. So these are the different ratings present in the rating columns, and this is the value count of each of the rating column. So to visualize this, we use a bar plot, and we can see that most of the Alexa got the 5-star ratings, some got 4, some got 1, 3, and the least rating is the 2. The least number of ratings is 2. So to find the percentage, we are just finding the percentage of each of the rating, and if we plot that visually, so we can see that 72% reviews are 5-star, and these are the other percentages. So the least is 3%, which is of the 2-star ratings. Next we analyze the feedback column. So this column refers to the feedback of the verified reviews. So whether it can be positive or it can also be negative feedback. So if we check the value count, so we got 1 and 0 as the two distinct values in the feedback, and for 1 the value count is around 2893, and for 0 it is around 256. Now if we check what the feedback value 0 represents, we can see that the review present at the 0 feedback value, it is sound is terrible, if you want good music to get a boost. So that is a negative feedback, and whereas we check for feedback value 1, the feedback is loved it, which is a positive feedback. Thus this means that the feedback value of 1 is representing a positive feedback, and feedback value of 0 represents a negative feedback. So this is the bar chart for the feedback value count. So one around nearly 2700 values have positive feedbacks, and some have negative. Then if we find the percentage, so 91% are positive and 8% are negative reviews. So yeah, this is the basically a pie chart for the same. So next we check if when the feedback value is 0, and we check the ratings. So when we check the rating, we will see that the rating which we see when the feedback is 0 is 1 and 2, meaning the least two ratings, the worst. And when the feedback is positive, the ratings are given around 3, 4, 5. So meaning that when the customers are writing a negative feedback, they are giving ratings of 1 and 2, and when they are writing a positive feedback, they are giving ratings of 3, 4 and 5. Then we analyze the variation column. So variations basically means the different types of versions, or different types of the, not versions but the different types of variants available of that Alexa. So it can be black dot, charcoal fabric, black plus, etc. These are the different unique values present in the variation column, and these are their value count. Next we visualize the variation distribution count. So this is the different variations, and these are their value counts. So more than black, we can see that black dot variation was the most loved by people, as it is bought the most and it also has the most reviews, whereas walnut finish is not people's favorite, and it has been bought by very few people. Then we get the percentage distribution. So 16% is the black dot variation, and only 0.2% is the walnut finish variation. Then these are the mean of the ratings for the each variation. So if we analyze the above ratings according to their variation, we can see that mean ratings are these, and these for the different variations. So this verified reviews column contains the textual reviews given by the user for variation for the product. So if we do the analysis, we can see that the distribution length of review is this, and these are the counts. So most of the reviews have like 0 length, and around very few reviews have a length of more than 2700 or something. Yes. And then if we check them individually for positive and negative feedback. So for negative feedback, we can see that the length is around 75, and then we got some 20 reviews which have negative feedback and have a length of 250 words, and some, even very few are there which have negative feedback and have written a very long feedback of around some 1700 words. And if we do the same for the positive feedback, we can see that most of the time the review is most of the reviews of around 450, 470 reviews having zero length, and very few have a length of more than 2700 words. Very few, one or two maybe. Then we are doing the review of a lengthwise mean rating. So here is the ratings and here is the length. So most of the time the reviews which have a 5-star rating are the having the most length. Means when people are happy they write more, and when people are not satisfied they just either they write very bad reviews, very long bad reviews, or they just don't write reviews at all. They just give the ratings 1.5 2-star ratings. So in the next step we are performing the count vectorization, and then we are plotting the word cloud for all the reviews. So if we plot a word cloud for all the reviews, we can see that Alexa, love, these are the mostly seen values. And if we plot word cloud for each negative and positive feedbacks, so for negative feedbacks we can see that the most commonly appearing words are repair, uh, horrible, something like 1 month's warranty, poor, stopped. These are the most of the words which are seen for negative feedbacks. And if we go for positive feedbacks, we can see love, Alexa, house, amazing. These are the words which are seen for positive feedbacks. Our next step is to pre-process and model the data. So currently our data is not pre-processed at all. So firstly the process of having the process of pre-processing the data is to firstly we will build a corpus for the verified reviews column. So firstly we will replace any non-alphabet characters with space, and then we will convert the words into their root format. So for that we are using the Porter-Stemmer algorithm, which is in the NLTK toolkit. So here we have created a empty list as corpus, and then we are and then on the verified reviews column we are basically saying that in every value which is not an alphabet present in the verified review, replace it with a space. Then we are converting it into the lower, which means the lowercase, and then we are using list comprehension and passing it into a loop in which it will check if the word which is present in the review is a stop word or not. So stop word is basically words which don't add meaningful value to our data. So for example, is, the, in, these are the different stop words. So if word is not present inside these stop words, pass it to the stemmer.stem, which means that if the word is not is and those types of words, then it will go to the stem object, and here it will be converted it into its root format. So what Porter-Stemmer basically does is it is used to convert words into their root format, into their base format. Now what this means is that, for example, we have words like running, jumping, cycling. So the base format for running, runs, would be a run. For jumping, jumps. The root word will be jump, and so on. So for that we are using the Porter-Stemmer, and we are passing the words which are present in the review into this. After this we are adding all the words which are again got into the review into the empty corpus. Now we are doing the count vectorization, and we are dividing our data into x and y. So we are now storing the independent and dependent variables in x and y. So we are passing the corpus into our x, and we are passing the feedback column into our y variable. Then we are saving the count vectorizer. Next we are checking the shape of our x and y. Then we are splitting our data into train and test set, in which we are dividing the data by 30%. And then we are scaling our data. Since our scale data is not scaled yet, so we are scaling it into the between the values 0 and 1. Then we are using random forest algorithm, and we are calling the random forest classifier inside our model underscore rf variable and passing the x-train scale data and y-train data for into it. Then we check the accuracy. We got an accuracy of 0.99 on the training data and an accuracy of 0.94 on the test data. If we use this to predict the do the predictions on the test data, and we are storing that in our bipeds model, then we are printing the classification report. So here is the classification report for the random forest model, which is given by the random forest model. And then we are printing the confusion matrix for the same. Next we are finding the trying to find the optimal parameters using the grid search CV. And then after getting the best parameters, we again do the accuracy on training and test set, and we got the accuracy of 96 and 92, 96 on the train set and 92 on the validation, which is on the test set, so which gives accuracy score of 0.94 for the test set. Next we are using the XGBoost classifier. So we are passing the data, and on this model we get the accuracy of 0.97 on the training set and an accuracy of 0.94 on the testing set. Then again we print the classification report for it, and again the confusion matrix. So this is the confusion matrix for the XGBoost model, and this is the step where we are saving the XGBoost model using the pickle library, and we are dumping it into our project directory. Then we are using the dysentery classifier, and with the help of dysentery we got a training accuracy of 0.99 and a testing accuracy of 0.92. Then we print the classification report for it and the confusion matrix. Next we are using the naive bayes classifier. So in this we got an training accuracy of 0.95 and testing accuracy of 0.92. Then we print the classification report and the confusion matrix for the same. This is the confusion matrix for the naive bayes. Next we are using the passive aggressive classifier. So for the passive aggressive classifier, we got an training accuracy of 0.99 and testing accuracy of 0.93. We print the classification report and the confusion matrix for the same. Next we have the SVM. So for the SVM we got the testing accuracy of 0.99 and training accuracy of 0.99 and testing accuracy of 0.94. We print the classification report for the same and the confusion matrix, and we then save the model using the pickle. And that is it for this video. Thank you.